Hello everyone, this is Nishant and my teammate Jashwant Gurjala. We are gonna discuss about research journey, AI-powered research paper assistant. So today I'm presenting a research journey, an advanced AI-powered research assistant designed to revolutionize assistance designed to revolutionize how researchers analyze and interact with academic literature. We built using cutting-edge technology including NVIDIA endpoints, LangChain framework, and vector databases. The system provides intelligent document processing, semantic search, multi agent validation, and dynamic literature discovery capabilities. Research Journey addresses the critical challenge faced by researchers, let's say, like efficiently analyzing large volume of academic papers, extracting key insights, verifying citations, and discovering related work. By combining retrieval augmented generation RAG with multi-agent validation systems, Research Journey ensures high quality, accurate, and contextually relevant response to research queries. Key achievements include 100% citation verification accuracy, dynamic AI XOVX, integration with customizable search filters, and a professional web interface deployed on Streamlit Cloud or global accessibility. Now let's go into this. So I'll give a project overview, where like let's say the problem statement, let's say, and solution. Let me explain the problem statement. Academic researchers face significant challenges in conducting literature reviews. There's an overwhelming volume of published research papers across multiple databases. Manual analysis and summarization of paper is extremely time consuming. Researchers have a difficulty tracking and verifying citations across documents. There's limited ability to discover thematically related research, and there's a lack of tools for intelligent question answering across multiple papers. The solution is Research Genie, a RAG-based application that combines advanced NLP, vector databases, and multi-agent systems to provide researchers with an intelligent, automated research assistant. The system processes PDF documents, extracts and indexes content, enables semantic search, and provides validated answers with citation verification. This project fulfills option 1 of the final project requirement, an AI-powered RAG application with vector database and LLM integration. Now let's go to the system architecture and review once. Research journey consists of three main processing pipelines: document processing, query and retrieval, and response generation. Starting with the document processing pipeline, the system accepts PDF files through the Streamlit interface using PyPDF2. Text and metadata are extracted from each document, including title, author information, and page count. Documents are chunked using lang chains with a chunk size of 2000 characters and 50 characters overlap. This ensures semantic coherence while maintaining context across chunk boundaries. A specialized citation extractor identifies numbered citations within document and stores them in a dedicated citation database. This enables later verification of citations in generated responses. Text chunks are converted to dense vector representations using NVIDIA's NV embedded V1 model. These embeddings are stored in FASS vector databases, enabling fast approximate nearest neighborhood search with sublinear search complexity. Moving to the query and retrieval, query and retrieval pipeline. When users submit queries through the chat interface, documents can be filtered by metadata such as author, title, and date to narrow the search space. User queries are embedded using the same NVIDIA embedding model, ensuring semantic consistency. Fastest performs similarity search against the indexed document vectors, retrieving the top 10 most relevant chunks. Retrieved chunks are re-ranked using Gina's relevance scoring algorithm that calculates Jacquard similarity between query terms and document content. This reduces the final set to top 5 most relevant chunks. The top ranked chunks are assembled into a coherent context window with a maximum of 4000 characters, with a source attribution and metadata. Now let's go to the architecture diagram and discuss in this. Uh, this research journey architecture diagram, which illustrates how all the components work together to provide an intelligent search assistance. The system is organized in three main sections, which we have already discussed about. This is what it says when it document processing, query and retrieval, and response generation. Here we can see PDF upload, text extraction, and literature scanner, in which citation extractor, vector embedding, fast storage, and then it goes to query and retrieval, user query, and then going with our Gemini 2.4 Flash metadata exert, and then query embedding such a way, and then to yeah, we can see a Girari anchor and context assembly, and retrieved context to GPT-4 synthesis, and multi-agent validation, citation verification, and display response with the same session memory and updating to conversation history. This is how we have represented in this architecture diagram. And then now let's go to response generation pipeline. Now the response generation pipeline, NVIDIA Llama 3.1, the 8B instruction model generates a response using the assembled context and conversation history. The model is promoted to provide accurate and citation backed answers based solely on the provided context. Here's where the multi-agent validation systems comes in. It evaluates each response across three dimensions: accuracy, which verifies that the response aligns with the provided context; relevance, which assesses how well the response addresses the user's query; and completeness, which evaluates whether the response fully answers the question. Each dimension is scored from 0 to 1 with an aggregate confidence score computed. If validation fails with a confidence below zero point 0.7, the system automatically regenerates an improved response. All citation numbers referenced in the generation response are verified against the citation database. The system checks whether each citation actually exists in the source documents, providing transparency and academic integrity. The system maintains conversation history of the last 10 interactions to provide context aware responses. This memory enables to follow up questions and natural dialogue flow. Each interaction is stored with its validation scores and timestamps for analytics. Now let's discuss about key features and capabilities. Let me walk you through the core features. Research Genie offers multi-document PDF processing, allowing you to upload and process multiple research papers simultaneously with automatic text extraction and metadata capture. The semantic search feature provides vector-based similarity search across all ingested documents using NVIDIA embeddings and indexing. Intelligent summarization generates AI-powered structured summaries including title, authors, abstract, key findings, methods, results, and limitations. The interactive question and answer system offers a context aware chat box interface for asking questions about uploaded documents with real time validation. Citation tracking and verification happens automatically when extraction, storage, and verification of citations with visual indicators. Multi agent validation provides three-dimensional quality assessment of accuracy, relevance, and completeness for every response. Result re-ranking uses GINA-based re-ranking of search results for improved relevance, and dynamic integration enables user-driven search of academic literature with advanced filter options. For advanced search capabilities, Research Genie provides three distinct search models for literature discovery. Simple search allows users to enter natural language queries and the system search directly without restrictions. Advanced search provides granular control with filters for author names, title keywords, abstract keywords, and categories, publication date ranges, and sort order. And AI-powered similar paper discovery automatically analyzes uploaded documents, extracts key term and concepts, and finds related paper on without manual query formulation. Now let's discuss about technology stack. For the front-end framework, we are using Streamlit 1.29.0, a Python web framework for rapid UI development. The LLM is NVIDIA Llama 3.1. The 8B instruct model accessed via LangChain NVIDIA AI endpoints. The embeddings model is NVIDIA Embed V1, a state-of-the-art embedding model. The vector database is Facebook AI Similarity Search in its CPU optimized version. The orchestration framework is LangChain, a modular framework for LM applications. PDF processing uses PyPDF 2 3.0.1 for text extraction and metadata reading. The external API is ARXAV API for academic paper search and retrieval. Visualization uses Plotly 5.18.0 for interactive charts in the analysis dashboard. Deployment is on Streamlit Cloud, providing free cloud, providing free cloud hosting with automatic CI/CD pipelines. Supporting libraries include LangChain text splitters for document chunking with overlap, LangChain community for community integrations with Fastest LangChain core for core LangChain abstractions, Python.env for environment variable management, and request for HTTP calls for the API. Now let's go through implementation details, and we'll discuss about user interface as well together. Okay. The project structure flows a modular architecture. We have attached the research assistant.py file, which contains all backend logic with core classes. In it is which uh, it will be attached with this files and GitHub also. App.py is also the other file, is the Streamlit frontend with 5 tabs uploaded, summarized, and question answer, search, and analytics. And all this will be discussed by my teammate in the next uh, next in the next interface of the video. um, So requirements are text lists, the other file that lists all Python dependencies with pinned versions. The .env file handles environment variables for local development only, and .git ignore prevents sensitive files from being committed to version control. For key algorithms, the document chunking strategy uses recursive character based splitting with 2000 character chunks and 50 character overlap. Relevance scoring implements Jaccard similarity coefficient, where relevance equals the intersection of query and document divided by the union. The multi-agent validation algorithm has each agent score the response from 0.0 to 1.0, with scores aggregated as confidence equals accuracy plus relevance plus completeness divided by 3. If conference is below zero point 0.7, an improvement prompt is triggered. Citation extracts uses a regex pattern to identify numbered citations and capture surrounding context, storing them with document ID, citation number, and 200 character context snippet. The user interface is organized. So the user interface is organized into 5 primary tabs. Tab 1 is upload and ingest with multi-file PDF uploader and process bars. Tab 2 is summarize with one-click summarization and download options. Tab 3 is interactive question and answer with chat-based interface and expandable quality metrics. Tab 4 is literature search with the 3 search models and comprehensive filtering. And Tab 5 is session analytics with interactive plotty charts and metrics. Now let's discuss about testing, deployment, and we'll go with results all together. Okay, now let's go with testing. For testing and evaluation, the system underwent comprehensive functional testing for PDF upload, vector indexing, question answer generation, and search. Performance testing showed document processing time averaging 5 to 10 seconds per PDF, query response time averaging 3 to 5 seconds with validation, and search latency of 1 to 2 seconds for 10 results. Quality assessment achieved an average validation confidence score of 78 to 85% citation. Citation verifications accuracy of 100% for numbered citations and high semantic search relevance in top 5 chunks. Research Genie is deployed on a Streamlit cloud with code pushed to GitHub. Automatic dependency installation, API keys configured via Streamlit secrets, and the application accessible via public URL. Yeah, for security, API keys are stored in environment variables and never committed to version control. These comprehensive error handling with try expect blocks. Input validation checks file types and sizes, and git ignores prevent accidental exposure of sensitive data. Then, yeah, we'll go with the yeah. Okay. The project outcome includes successfully implementing a complete RAG pipeline with 8 core components, achieving 80% plus average confidence scores, successfully handling document with 100 plus pages and 1000 plus citations, deploying a publicly accessible web application with 99.9% uptime, and integrating with 50 plus search capability per session. Now let's discuss and then final like we'll go with challenges, future enhancements and ethics. Technical challenges include LangChain module reorganization with which was solved by updating all imports to use the new package structure. Streamlit secrets error handling was resolved by implementing try except blocks with multiple API key source checks. Search result quality improvement improved by redesigning to be fully user driven with dynamic query building, and response validation reliability was enhanced by adding robust rejects pattern matching with fallback scores. The future enhancements planned the future enhancements planned planned features include multi-model support with GPT-4, Claude, and Gemini, advanced citations analytics with graph visualization, collaborative features for uh, shared collections, export options in LaTeX and Word formats, database integration with PostgreSQL or MongoDB, and REST API development for programmatic access. Scalability improvements include GPU acceleration, distributed vector search with Pinecone, batch processing or large collections, and caching layers for frequently accessed documents regarding ethical considerations. Um, just go regarding okay, okay, regarding ethical consideration, the system process uploaded documents for analysis under fair use for educational and research purposes. Citations verification ensures academic integrity by validating all reference sources, and for data privacy, all processing occurs within the user session with no permanent storage. Session data cleared on reset, and API keys encrypt in transit. So we'll come with what are the learning outcomes and conclusion. For learning outcomes, I acquired a deep technical skill in RAG architecture, vector databases with fastest LLM. Uh, I mean with Facebook AI services, LLM integration with prompt engineering, multi-agent system implementation, web development with Streamlit, and DevOps include Git workflow and cloud deployment. Key learnings include yeah. So key learnings include understanding the effective AI system require more than powerful models. They need robust validation, clear user feedback, and careful prompt engineering. The multi-agent validation system proved essential for maintaining response quality and user trust. The importance of user-centered design become evident with refactoring ARXV search to be user driven. Finally, in conclusion, Research Genie successfully demonstrated the power of combining retrieval augmented generation RAG with multi-agent validation systems to create an intelligent search assistant. The project achieves all stated objectives, like deploying RAG application, implementing semantic search capabilities, creating an intuitive streamlit UI, achieving high quality responses through multi agent validation, and deploying a production ready application accessible globally. The system serves as a practical tool for researchers while demonstrating advanced AI engine principles. Generative AI can augment human capabilities in knowledge in intensive tasks and provide a solid foundation for our future expansion. So the next UI and a clear explanation of UI will be taken by my group mate, my teammate Jashwant Gurujala. Thanks for your time. Jashwant will take over. Thank you.
So taking off my co-teammate Nishant, I will be like proceeding with the demo. So I will go to the brief of the system architecture and I will jump on the demo of the interface that we have created. So first the user will upload the documents. Let's say like researcher have to do a brief on the 10 documents or 10 research papers. So he will upload the documents and text extraction will take place. And the literature scanner agent and the citation extractor agent will comes into effect and divide those into separate and it will store as embeddings in a vector database. We have used FAISS storage vector database here. So this is the Research Genie interface that we have created and hosted on the Streamlit app. So it does basic multi-agent validation and citation verification and the Gina Ranker dynamic AR XIV search agent. So for the user, I have uploaded the document here and I will process that document so that it will create the indexes of that document and it will store in the vector database. Yep. So when I go to the summarize, it is creating the generate summary. If I click on the generate summary, so it's here where the retrieval augmented generation thing takes place. It will retrieve from the document from the vector embeddings that are being stored in the vector database and it will list out the authors and like brief summary of the paper that I have uploaded given to the research genie. So this paper says about the small language models are the future of agentic AI and so on. So the next feature that we have given here is an user can do Q&A session on the paper that is being uploaded by the user. Let's say if a user want to do a query based upon, let's say I have a question, how will small language models help in the domain of finance? If I pass on this Q&A on the specific paper that I have given to the ARX research genie, let's see what will it give. So it says in the domain of finance, small language models can be highly beneficial due to their flexibility, fine-tuning capabilities, and scalability. So in this way, the researchers can do the specific question and answer basis thing. They can query on the specific thing that they have been uploaded. Here, the multi-agent validation takes place that it will calculate the accuracy, the relevance, and the completeness and the confidence of the answer. So this thing. And what does this ARXIV agent does is it will go to the ARXIV API and it will hit the API. Let's say if the user has uploaded a paper related to the machine learning uh, or computer vision deep learning, if they want to like extract many papers, more papers related to that, so they can just like select the topic or uh, select the topic so that it will get the more papers that are being listed on the ARXIV. So these are the papers that are pulled out from those. So you can like basically change the result count that you want. Like let's say if you want 9, it will do as 9 or 10, whatever the results you want. And you will go through these papers. So you can go as it is listed, you can go from here, or you can download it in the PDF itself. So this is one future. This is basic simple search. When I go to advanced search, you can list out the author name, the search query, and the yeah, exactly category. If you want to list out any specific category, let's say if you want to do like machine learning, practical research, or sort results, or the time period, you can those do those. I want to get the papers in the last year itself, and I want to do machine learning related. So, and I want to get results like 10 results. So it is like it will get out the papers that are being related. So this is the AR XIV agent that it does the API calling and it will do the things. So in this analytics, we can see the tasks that are being used by the input user that are being listed here, and the number of queries are done by the user. This is like basically analytics tab that is useful for the monitoring of the app, or like if they want to jump into their previous query or those. So this is the demo of the Research Genie project. Thanks for listening to us. If you have any doubts, you can reach out to us on the details that are being mentioned on the GitHub.